The first type of elastic modulus we're going to look at is the Young's modulus, and this one, maybe sometimes a confusing issue with it is the fact that it's called the Young's modulus. You might say, well, what does that have to do with what it actually describes? And the answer is nothing, because that's the name of a person. If you want to go and look up more about the physicist that it's named after, I'd say that's maybe something you could do. I don't know that much, except that I do know it's the same physicist who originally found the evidence to convince physicists that light is a wave or has wave-like characteristics, although this predated stuff like understanding that light might also be a particle in the sense of a photon. But anyways, that's a whole other story. But his name also appears here with the Young's modulus. And maybe to start with, like, what does it describe? I've got a couple pictures here in my whiteboard that I've gone ahead and penned in before we started that sort of show what the situation might be like. One of them, this is meant to be like maybe a rod, could be made out of metal, maybe something else, but it's rigid. And it has a cross-sectional area A, and I'm imagining applying forces at both ends as a form of a stress applied to this rod. And the deformation that it's going to express as a strain is a change in its length. And the strain is expressed as the ratio of the length change to what the unstressed, or maybe you could even say unstrained, I guess, but whatever, length. Now, there's whatever length it had before forces were applied. And given the fact that any kind of elastic modulus is generally going to be the ratio of stress to strain, it might make sense the formula that we have here on the key concepts page, and I've also listed it over here, is the ratio of kind of those two things that themselves are also ratios. I've listed down here two other formulas that I've seen in some different textbooks that maybe lend themselves to certain types of questions. Like if you have a question where it says, here's an amount of length change, which could be described in different ways. Here's the Young's modulus. Here's all the other information like area and length. Tell me how much force was applied. This formula, of course, lends itself to that and was basically arrived at by algebraically manipulating this original formula. I like to always start, though, with this formula. This is the one that I find easy to remember because it does tie back to the stress over strain concept, and it really is the definition of the Young's modulus. But again, I've seen some textbooks that emphasize these other formulas because they lend themselves to applied questions, like this second one as well here. If instead of asking for the force, they gave it to you, but they wanted to know what's the length change, either in terms of like a stretch or a compression of some kind, this formula would lend itself to that type of a situation.